Okay, so today's lesson is simplifying expressions using the distributive property. So we'll be talking about, you've probably done it a little bit with the distributive property in 6th grade. We'll be using it to simplify expressions, and we're going to do the reverse of using it to simplify to kind of go backwards and factor expressions. And then again, we're going to determine whether expressions are equivalent using this new property. Okay, to use the distributive property, the word distributive means to distribute. So if I were going to distribute candy to all of you, I would be giving each of you a piece of candy. So when we use the distributive property, we're taking the term in front of the parentheses. This example says 2 times the sum of x plus 1. We're going to distribute the 2. We're going to do 2 times x. And then we're going to do 2 times positive 1. You want to make sure you include any negative signs that might be in front of the number. So in this case, it's just positive. So when I do this, I end up with 2 times x is just 2x, and 2 times 1 is 2. So 2x plus 2 is the same expression as 2 times x plus 1. We could check that by using a number. Let's let x equal 1. If x were to equal 1, we'd have 2 times 1 plus 1. If we follow order of operations, we do what's inside the parentheses. 1 plus 1 is 2, and 2 times 2 is 4. If we let x be 1 for our simplified version, we have 2 times 1 plus 2. 2 times 1 is 2. 2 plus 2 is 4. So if you're ever not sure when you've simplified something, if you simplified it correctly, you can always check by substituting a number in. Okay, so the next one, again, I'm going to distribute 3 times x and 3 times 4. So we get 3x plus 3 times 4 is 12. Okay, next one, Reed. Tell me how I would do the next one. Okay, and get
6x.
good.
And then you would do 3 times 1.
Mm-hmm.
And then get
3. Good. Okay, easy enough. Go ahead and do the next 3, and then we'll talk about them. Okay, the first one, Eli, what did you get as an answer?
5.
Good. Next one, Jake.
2x plus 18.
Good. And the last one, Elena.
12x plus 12.
Good. Any questions about this slide? Okay. Moving on. These are some examples that have negative signs in front. So when we do these, it's negative 2 times x, negative 2 times 7. So we end up with negative 2x minus 14. You also can write plus negative 14, but it's better in algebra not to have too many extra signs. So even though it's an accurate thing to say, plus a negative 14, it's better to write it as negative 2x minus 14. So I prefer you do it that way because we are moving into algebra. We want to keep things as simple as possible. Jimmy, how would I do the next one? This one?
Negative 5x plus negative 30.
Instead of writing plus negative 30, though, let's just write minus 30. Okay, next one, Eve.
Negative 4x plus, or minus 8.
Minus 8, good. Okay, I'll give you about 30 seconds to complete these 3, and then we'll go over them. Okay, Grace, first one.
Negative 9x minus 9.
Good. Reagan, next one.
Negative 8 minus 16.
Negative 8. You need this too.
Oh. -8x.
There we go. Yeah, be really careful that you don't accidentally leave out the variable because it would technically be wrong there. Ross, next one.
-3x minus 15.
Good. Okay, the next slide includes some examples where there is a minus sign within the parentheses, as well as the negative sign in front of the number before the parentheses. So don't forget, when you multiply negative times a negative, you're going to get a positive answer. These are the kind most commonly forgotten because people a lot of times don't pay attention to this negative sign. They kind of forget about it. We have to think of this as -3 times x, which is -3x, and then -3 times -4, which is positive 12. Sky, can you try the next one?
-4 plus
-4
x
x
plus 12.
plus 12. Good. Kaylin, next one.
-4x plus 16.
Good. I'm just going to go on with the you tries and have you guys do these on the spot. Violet, next one.
-5x minus 5.
No, not -5. We have -5 times -1
Oh, plus 5.
plus 5. Adria, next one.
-7x plus 14.
Good. Michaela, last one.
-4x plus 20.
Good. Okay. Next objective, to use the distributive property to factor expressions. So when we factor expressions, what we're doing is we're doing the reverse of what we just did. We're figuring out what could we take out of both of those numbers. In other words, what number goes into them by division that we could take out, put outside the parentheses, and leave something inside. So what we do is we look at the coefficient in front of the x and the constant, and we look to see if there are any common factors. And specifically, we want the greatest common factor. Grace? 2. 2 would be the greatest common factor. So we're going to take a 2. If we take a 2 out of the 4x, we're thinking how many times does 2 go into 4x, or 4 divided by 2 is 2. 14 divided by 2 is 7. Okay, the next one, Taryn, what would the greatest common factor be for 12 and 6? 6. 6 would be, 2 is a factor. You would get an equivalent expression, but you wouldn't, sometimes the instructions will say to factor completely, which means you need to use the greatest common factor. So 6 is our greatest common factor. We're going to write that outside the parentheses. Taryn, what would be left if we do 12y divided by 6? 2y. Minus 1. Good. So these are a little bit trickier. You have to think a little bit harder than the other ones since we're doing division instead of multiplication. I'm going to give you a minute to try these 3, and then we will talk about them. Okay, we're going to go over these. Zoe, what did you get for the first one?
Negative, or, 3,
Uh-huh.
and then 3x plus 5.
Good. 3 is the greatest common factor. 9x divided by 3 is 3x. 15 divided by 3 is 5. McKenna, what did you get for the next one?
I got 12
Good.
and 3 plus 2t.
Excellent. This one, I saw a couple factors other than just 12. A lot of times people don't think about 12, but it definitely is 12. If you used something, somebody tell me, if you didn't factor it with 12, someone tell me what you factored it with instead. Reagan?
I did 6.
Okay, so Reagan did 6, so she would have had 6 times
6 plus 4t.
Now here's how you know that you didn't factor this completely. If you look at the 6 and the 4, it's like reducing fractions. This isn't as low as it could go. You could also take out, you could look and say, oh, I could have taken out a 2 from this. So if you take out a 2, now you have a 2 and a 6. 2 times 6 is 12. 6 divided by 2 is 3. 4t divided by 2 is 2t. So you can still kind of work from there and factor it down further. Pat, next one.
I did 4.
Good,
And then 2c minus 5.
good. Okay, any questions about these? Okay, last objective, equivalent expressions. Are the expressions equivalent? So in this case, we want to simplify both sides. The left side is already simplified as far as we can go with that one. So we're going to look at the right side. I'm going to use the distributive property. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. So I can see now that I have the exact same expression as I had originally. So I would say, yes, those expressions are equivalent. And if you're not sure if you did this right, again, you could substitute in a number. So you could look at the original expression. You could say, well, if I put a 1 in for x, I'd have negative 3 plus 3, which would be 0. If I put a 1 in for x here, I would have to do what's in parentheses first. 1 minus 1 is 0, and 0 times negative 3 is 0. So that's another way you can check. But I want you to use distribution first. When you get down to the problems at the bottom, on one of the sides you need to combine like terms to get the most simplified version of the expression, and on the other side you have to distribute. So take a couple minutes and simplify these expressions to decide whether or not they are equivalent. Okay, let's take a look at these. Riley, 4x plus 12 and 4 times the quantity x minus 3, are they equivalent? No, why not? What do you get when you simplify 4 times x minus 3?
I got 4x minus 12.
Good. And 4x minus 12 is not the same expression as 4x plus 12, so the answer is no. A lot of times when I give you these problems to do on tests or on your exit ticket coming up, it will say, are the expressions equivalent? Prove your answer, so it's not sufficient just to tell me yes or no. I noticed some of you just had yes or no written down. You have to prove why by simplifying the expression. Okay, next one over here. Braden, are these expressions equivalent?
No,
No, why not?
because the first problem you get -2, and the second problem you get 10.
Negative 2. Okay, you would get, what were you doing to get those? Did you put a number in? You put 1 in? So did you substitute a 1 for x and that's how you figured it out?
No, I just used 2x. I added -5 and 1.
Oh, okay, okay. So tell me what your simplified, your whole simplified expression here is.
2x plus -4.
2x plus -4, okay. Or just, let's write that as 2x minus 4. Okay, and then over here?
2x plus 8.
Okay, good. 2x plus 8. So 2x minus 4 is not the same expression as 2x plus 8. And again, if you're not sure whether you've simplified it far enough, you can always substitute a number in to check. Okay, last one. Katie, are they equivalent expressions?
So,
No? Why not?
because I got for the first one,
Mm-hmm.
4x minus 2, and then the second one,
Okay, then what did you get for the second one?
they are.
Okay, good. You caught yourself, okay? So you also get 4x minus 2. So the answer is yes. Okay, any questions about any of this? Did you think this was a pretty easy lesson? Okay, I think your exit ticket cards got passed back, so here is your exit ticket.